Yeah, 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 this is true. This is true. My Linux system has not never crashed the last years. PC does automatically updates itself, and I don't know when it does it, because sometimes it does it in the afternoon, at night, in the morning, when it wants to do that, and I have to care afterwards if everything still runs. So it would be better for me to say to skip updates. So back to our theme. We want a little more talking about mobile computing and Android programming. We've already talked about lots of historic things, why Android operating system, why it is so widespread, and what is the what does mobile computing mean? It is not only programming software for a smartphone or a smartwatch or a tablet. It sometimes does mean lots more things in the background you do not see. You have to you have the need of different kinds of networks which give you the possibility of using devices in a mobile environment. We have the applications not only on the devices, because the devices could be used offline or online or both. We have applications in the background and so on, and that's why we have to produce applications which are depart on different systems. Parts of our application are running on servers in the internet, other parts on the mobile devices. How do those devices communicate with each other and so on? Do they always have the need to communicate over the server? Do they always have the need of internet connection? And these are questions we can afford if we say what is mobile, what is fixed in our environment in which we place our application then. But this was last week, and this week or today we want to learn or see some more things in this development environment we talked about. We need an Android SDK. We want to have a look into this Android SDK. What do we have inside? Oh, I know, I didn't find it here on my PC because I just used this IntelliJ, and this IntelliJ has installed the Android SDK somewhere. So we have to find out where is the Android SDK installed on the system, and can we look inside. I wanted to check it before we start this lecture, but I forgot it or didn't find enough time to do this. I was interrupted when I was looking for. So maybe we have here some experienced developers, and we can help each other to find out where is our SDK locally installed and how we can see it in the file browser in the Explorer. This is one task we want to do, and we want to see the command line tools and have a look what they are for and what they stand for, what comes all with this SDK, what is inside, and what is then controlled from the IDE. If I push some buttons here, which tools are running then in the background, and the outputs are produced in those windows, in those departed windows here. The Android Studio is a brand from IntelliJ, so we can use the IntelliJ IDE or the Android Studio. Both is the same. The Android Studio is just branded. It has another look and feel, and maybe some other tools which are not included in the standard IDE, but if you want, you can use the standard IntelliJ IDE. I have the edition. We have used it for our Kotlin programming, and the same thing is we can use it the same for Android programming. Where is it gone? No, this one. I have several windows, and every window is for another project. So this was our Kotlin project in this IntelliJ, and we have there different kinds of help topics, and we can introduce several more plugins, and there must be somewhere a plugin installer for bringing new stuff into this IDE. I'm not sure if maybe it is part of the tools. No, it's not here. The guys who use this IntelliJ with the Android as well, maybe you know where it is found in the menus, and can give me a hint. I thought it is under help and should be somewhere here, but as you know, it sometimes is not so easy to find out where it is while you are doing it. Yeah, so this is not the one. And check for updates is just looking in the background. We don't want to do this, so I thought it must be under help or under window, but it is not under window, and it is as well not under this other. So we have somewhere a tool which is appending or introducing new plugins for this program here. That thing is to go into our module settings or into the settings. My internet connection is unstable. Oh, I hope it will last. It will last. We have settings for only the project in this way, and this is a Kotlin project here. We have platform SDKs, and this platform SDK you see here, we have Java SDK 15, we have the Android SDK, and there we have the path where the SDK is. This is what we were looking for. The SDK or the platform is downloaded in the app data local, and there we have a look now. We want to follow this path. It is in my home directory in the app data local and then Android SDK. Let's go. Plugins in the settings in IntelliJ. Plugins in the settings in IntelliJ. Okay, thank you. So we have somewhere the settings, plugins in the settings. Okay, let's have a look.
Under file.
Under file, yeah, under file.
Settings, yeah, under file.
Site settings, yeah, thank you, I found it. Okay, we have the under file, we have the settings, and there we can control everything, and there's as well these tools or plugins here, plugins. The plugin manager to bring something from a marketplace. Thank you very much for this hint. To bring several tools into the IDE and make it do or get some more features running other languages, and as well the Android toolset should be there in this part as well. But I already installed it. I should go to installed, and you see under my installed plugins I have the Android, and this was already bundled, so it is possible to use the community edition, and it comes with the community edition. I have downloaded the Kotlin release 1.4, and the other tools were already there, the Gradle, Maven or Ant build chain, tool chain is there, and other stuff. But here you have always the possibility to get your tool set you need and several more things. Thank you. Okay, good. But we found out where it is now. We have seen it is in the app data local, so let's go to the app data local and have a look in this SDK. There we have Android SDK, and here it is. This is the Android SDK file structure, and we can go there as well with a command window. I am already in this users, and then I go into app data local Android SDK. We see the same directory, but here now in this command window, and in the command window I have the possibility to start different things directly from command line. Okay, let's give an overview of what we are looking for before we go. An overview of the SDK which we are working with. We have build tools directory there. There are build tools installed. You see lots of programs, running programs as executable files, and there is something like APK signer. APK is a short form for application package. That's the outcome what you are installing on the Android device. And if you remember, you use Java, and you have a bunch of classes. One of those classes is maybe your startable file with the main function inside. Then you can combine your project structure with your classes and packages to a Java archive called jar, and this jar file could be a runnable jar file. It could be signed so that you see, okay, there is a certificate inside, and you signed this because you are the manufacturer, and then we trust your code. And this is the same thing like here. We have not a Java archive, but just another name for a similar thing. It's similar. It is a archive. It is maybe the same algorithm. You can open it with the Java archive program, but inside are some other things the normal Java virtual machine is not able to recognize, and we will go and see what it is. So this is one of those tools. So if you have jar and jar signer, we now have APK and APK signer. There must be some other program doing this APK too. We have a DEX program. This is a batch file here, but it should be DEX somewhere. Maybe we have another tool set on in another folder, but there is this DEX program, and this is the program which creates the bytecode. It is called DEX, a program creating our bytecode. It's something like compressing our bytecode once. So we do lots of compressing with our code, with our resources, and this compressed data goes into a compressed archive. So what else do we see here? So some more tools until zip align. Other files, applications we have here, and this is a batch file, but it must be somewhere a DEX program. So let's go into another folder and look into there. What else do we have? We have a emulator. Emulators are going here. In this emulator directory, we have a application called emulator, and we have several emulators which are downloaded somewhere. We have maybe those QEMU system files available, because this emulator is using QEMU to emulate images. Yeah, this is the system of the emulator. The emulator is just a image file from a running Android kernel version, a standard installation of a complete Android system, and this is emulated with QEMU, so we run it in a virtual environment. That's all. And these QEMU files give us a virtual environment for our Android system, so that it can be run in a 64-bit kernel system, or a older version, or a smaller architecture as well. Yeah. Therefore, we have those tools here, and this is a program running the emulator. What else? Extras. There is something we have if we use Intel CPUs or Intel boards, motherboards, we can additionally use some speed up for our virtualization. Therefore, this HAXM driver is supported. It is extra, so it is not basically not in every SDK. You have to download it if you use your if you develop on a machine with Intel chips, with Intel main processing units, and then you can install it to make your emulator a little bit faster, or get lots more speed. So fonts, I don't know, some fonts here is empty in my case. What else? Licenses. Normally we have a public license here to use this Android, and then we have platform tools. They are really important. In this case, we have a SQLite installation there to have somewhere a file system, and we can expect, if we use the emulator, the files I create with my applications. I could install maybe WhatsApp in the emulator and try to use this WhatsApp via the emulator, and the WhatsApp is using, or other Facebook application, other applications, every application you have available in the application store, because your emulator is a complete running Android system. So it could be on a phone. It's the same, just virtualized. And you can install everything you are able to install on a similar smartphone too. But now you have all the files on your file system. And on your file system you have root access. So you are able to access all the files your application you want to inspect is installing. And that's why you have the great advantage to look into the data other applications are collecting and storing on the phone, while they are not connected to the network, to the internet or so. And therefore you need some more tools. And one of those is SQLite, maybe, to access those database files, which are in most cases part of applications who use those databases. What else? We have a tool called Fastboot. This is a tool which allows you to communicate with the bootloader of your smartphone, and say, bootloader, you have to install a new update for my maybe my running Android system, and then the bootloader can be rerun and install, go into a installation mode and install a new Android operating system image on the phone. So with this tool set you have not only the possibility to develop applications for Android, you have also the chance to back up your phone, to restore your phone, to reinstall new system images. And if you download the open source of the Android source code, you also have the chance to build your own Android operating system version. All you need is a running kernel. The Linux kernel is not part of the Android operating system open source that you download, so you need a running Linux kernel for your hardware where you want to have the operating system, the Android OS, run with. But if you have a kernel, and especially if you have the kernel sources, maybe you take a vanilla or any other standard Linux kernel where the sources are open as well, then you can problemless get both together, compile it together, and get a runnable image. And this image you can install on every device which supports your kernel version. So if you know the CPU version at least, and if you know some standard hardware at least on this device, then you are able to build up your own version of the operating system OS. Okay, this in short. It's not part of our course, but you have the tools to install new things. This is called this is fast boot. And we have another very important program, the Android Debug Bridge. With the help of this debug bridge, we can connect with a running Android system, so with the running kernel, and we get maybe a shell and can give commands on the system. We can start and stop applications, we can start and stop services, we can bring a device into a network, so we can reconfigure devices with the help of this debug bridge. It is a very huge, very important tool. So with the help of the debug bridge, our IntelliJ installation is installing software, is deleting software, is managing software, is clearing the cache, is updating things. Everything is done from this. So we will definitely have a closer look to this tool. And for that, we should start a emulator and have a look what we can do with this tool, how to connect with the running emulator, and what to do on the command line. And what you can do with this, you can you can do it with every phone. So if you connect your phone, you have access to your phone, but you do not have the root access. Therefore, it is more difficult to inspect things that are on a productive configuration, so on your running phone, but better to do it with the emulator. If you want to inspect software, install it in the emulator and then check with the debug bridge, and then you have maybe access to everything. Or you take your operating system tools. Maybe you have a Linux system, then you can inspect the image files from the emulator as well, and you can see every piece of byte, every piece of data any application writes down. Good. So for what else? Some tools to make a file system, to create file systems, to create maybe new SD cards also, which are connected with the Android device. So for that reason, we have some tools additionally here. What else? Some annotations, so it's not so important for now. Let's have a look here. Standard C library is there. Okay, what is in systrace? So those are the most important tools. This is ADB and fastboot. So my connection is unstable. I'm not sure if you have interruptions while I'm talking, but I hope not so. I hope it's not so bad. Good. What else do we have inside this? We have some skins. So there are some skins available. You see those device names. These are the newer ones, the Pixel ones, and then we have the older ones, the Nexus ones. Those are the Google skins. We have the Nexus 1 skin, and what is it? It is just a number of images, and this is a blue screen of my phone, and this blue part will be replaced by the output of the graphics of any application. So there could be the home screen, there could be any application inside. This is just the surrounding of my phone, so that the emulator is giving us a look and feel of a phone device. And we have some buttons and some other things here. So it's no rocket science to create a new device. So if you have the ambition to create a new device, you can do it problemless. Give me a moment. There was a ring on the door. I just go to the door. Wait a moment, please. Excuse me, please. It was maybe just fun. I don't know. There was nobody. Good. Let us go on with those skins. So we have here some mostly images inside of those folders, and those images are named in some format. And with this, you can see this is a landscape and this is a portrait format for the image, and what we have is a HTML document as well. So we do not only have PNG images or JPEGs, we can have HTML documents. Let's have a look into this. It does not look like a WebP, so it's compiled. Is some compiled file. It does not give us more information. Okay. But you could open it with Microsoft Edge. Let's try. Open it with this Microsoft Edge, and it looks like this. So it is a image like some wireframe maybe, which forms a device. You see, it's a scalable, a little bit of scalable image. There is something can make it bigger and smaller. Maybe these are the surroundings of a device. Good. What else do we have here? So creating own devices, you can just maybe try to edit those files and make a new folder, and then you have a new look and feel of your device. It could be a TV. You can try out those devices which you have and create several emulators and say my emulator should be a Android 10 running on a Nexus 7 look and feel, but it's just the images. Yeah, so the core of your emulator is the virtual machine, and the look and feel can be skinned. If you have questions, then feel free to ask. Android, where we have things there. Okay, skins. What else? Platforms. We went over this folder a little bit too fast. Platforms are the platforms installed. So you see these numbers here are the API version numbers. This is the latest productive version number from Android 11, I think. It's the Android AP number 30. And here in this folder of this SDK platform of this API version numbers, we have everything special you need for your API version. There are resources, lots of resources which are available on every device which is accordant to this API version number. So these resources are available on every device which has API version 30, and you do not have the need, and we talk about hopefully we talk about later today about resources too, but I'm not sure. I think next week we talk a little more about resources. So you still have lots of resources, and let's go into this. And there is only one file, but it's a file called strings. We could open it with a notepad, and we see lots of a little bit, not lots of, here are some things inside, and this is a string name, and we could use this string name too. So if we inspect a little more the resources that are already available on devices we are going to program for, we can share this data. We have access to this data on the running phone, and when we talk about resources, we come back to this theme again. But we already found them. We already have found out resource files, lots of resource files inside this SDK package. Yeah? All XML documents, we can use them. We could derive from them as well. But and you find them nowhere online. You are not. There is nothing. They are not so well documented. If you want to, this is XML. If you want to know more, you have to go into those sources. You know? So and look what they are doing. Try them out. Check them out. It's lots of time you can spend to check them out. Okay. What else? Annotations. Okay. API versions and some other text documents. Maybe you want to read some things, what is in there, but the notepad, this notepad is not the best, maybe this one. And we have here lots of interesting names. We have Android View, Surface View, Android View, and I don't know what this means, what kind of information we find in there at the moment. Good, resources. So we found out lots of resources in this Android version 30 here, and annotations, activity actions. Interesting. Let's look at activity actions. Here are activity actions defined, which are available on this API. So it's a list of actions you could refer to. You could maybe use them with intents, but if we talk about intents, those actions are very important for us to use. And maybe we have here a overview which kinds of new actions have been made available, or which kinds of actions are possible to use in this Android system to catch, to send, and so on. This is a document. Let's have a look into this. We have API version 2 here, standing here, and there is manifest permissions. We have information about that. We have some deprecated stuff here. Bind carrier messaging service since API version 22, deprecated in 23. So things. We have maybe the application IntelliJ is looking for things and says, okay, in this API version you use some deprecated stuff, and it is then taken out or marked as in your code while your program. So you have things which are removed or in the code. Quite interesting sometimes, but not at the moment. Not so much at the moment. Go back to this. We have executable jar file. There's Android inside, and Microsoft PC. I don't have a possibility to open this file here and to have a look into this. If we would use or if I would use, must open this executable jar file and have a look inside the Java archive, and then you see the classes here inside. I'm sure. So I'm sure you see inside the Java classes. Or the text classes here for this Android SDK version in the API version 30. Good. Questions for this? Let's have a look in optional. We have some optional, also code. So if you have executable jar files, there is code inside. This is your classes. This is your API you want to use. So if you import this in maybe a project, which is, I'm sure, automatically done when you create a new project in IntelliJ for this Android SDK version, then this is automatically imported as a library, and then you have access to those classes. This is also your source, and you choose it. If you program for this SDK, you have those classes and compatibilities in that file. So really good. And the same thing in other versions, so the same files we find here, but in different versions. So just the version number is changing, and the folder is resources, nearly the same. So if we check the size of those folders, we will see that the sizes may not differ so much. This is 82 megabytes, or on disk 103, and the others have a size of 129 or 109 here, so 30 megabytes more about. So it's got less, and less means they have taken out, deprecated or removed things. Yeah, it is smaller. It got smaller. The newer version got a little bit smaller than the older one because of compatibility reasons. Downwards compatibility, you see it was 100 or on disk 121. Then we got a bigger Android version, and at 8 the size is decreasing because they are removing lots of things which are now, or which were deprecated for a long time, and they have taken them out. So if you will be or if you will have your code running with deprecated features on the new phone, you have to find archives and bring it with your own package. So if you miss something in the application version 30 because they took this out, you can have a so-called compatibility Java archive which has the old classes versions inside. The class names are, or get a name compat appended. Then you have the old version of the class. It's a compatibility version, so that you are able to use older APIs in newer phones, and those older APIs you then can put into your application package and bring them with your phone, so you have some kind of compatibility library, and this compatibility library makes your application run on newer SDK library versions but using older APIs. It makes but this approach of using those compatibility libraries makes the programming of Android applications a little more complicated. Because it's out of the normal APIs which are delivered on every phone. What else do we have? So we had this one, that one. Tools. No, we have not been in tools. And in tool, yes, we were in tool. No. Have we been in tools already? So emulator we have seen already. ProGuard is another thing. There is available. We have Ant tool chain there. We have here a ProGuard. Process guard is these annotations as well, but we had some more things. We have in this library, we have the monitor. This is a little bit how to say, not directly on the level above. We have an application here. It's called the monitor. It's the Android device monitor. Normally we should not start it from the command line, but I tried to start it here and it says Java was started but returned, so we are not able to start this outside of the IDE. I think we can give it a try. We go into tools and into the library and into this monitor. And now try to use this monitor exe, or here we have a Eclipse EC program to use it maybe in the Eclipse. Normally it shouldn't run outside the emulator. I get the same problem again. Code, and therefore I have to use, I'm sure I have to use another Java virtual machine, not this one I have available here in this Java version to get this run. But I think it is the same my IntelliJ is using, but so I'm not sure why it is not running. I should expect it maybe a little more later on. So this is a device monitor. This device monitor has the possibility to check every running process on the device, to check the load the processes produce, to check the network connection, to check up the log files, to check up how can I say, You have the possibility to see what is presented on the screen. So you have a live screen connection, and you can see the screen of your phone on the monitor. This is always monitored, so the screen or the camera or what you want. You have thread. You can debug with this monitor. You can go into threads. You can see variables. You can see method calls. Lots of stuff. It's a very huge tool, and it is normally integrated into your IDE, so you do not use it standalone. This was maybe 5 or 10 years ago. You could use it standalone, or you still could use it standalone out of the box, like I did here, or with a double click there. But now it is just integrated in the IDE. That's why we see it later if we go into IntelliJ and make our project. Good. What else? Yeah, some not so interesting things. And we have here monitor. Oh, maybe I should start this monitor. Let's see. It's the 64 bits monitor. And we have a error in the log file. Okay, let's go into the x86 and 64 and give it another chance to start over this monitor. I get this error, and now I get the same error. Yeah, you see, I get the same error again. That's not nice. But if I try to start it here, you see, yeah, it's this a Eclipse symbol here. Maybe this started in Eclipse, and I get here another error in the configuration, and this log file there I get more information. So go into this configuration and and let's have a look in this file. There it is. Why Java was not able to run. This is the command line arguments, and then we have a no entry, and here an exception occurred. Framework event. It is org Eclipse. So this tool is using things from Eclipse, and I do not have Eclipse installed. Yeah. So this is the first thing. Here's a error. Maybe this was the error why it is could not be resolved. So the bundle org Eclipse Equinox common could not be resolved, and I'm sure I do not have it because I do not have Eclipse installed. And if it is in there somewhere, org Equinox, maybe it is here, and then my class path is not set. If it is here, and if it is delivered with this application, let's have a look. Eclipse common 3.6, and we have here no Eclipse common. Yeah, there's no Eclipse common in there, so it is not here, and that's why Eclipse core platform here is as well. It is not here. Org Eclipse core, org Eclipse. Yeah, we should have a look. Maybe org Eclipse Equinox and UI. No, it's not here. Equinox common. Let's have a look. Equinox. There was Equinox common there. 3.6. This one. He has not found. Could not be resolved. So this is a class path issue, and if we want to start it via command line, we should fix the class path issue, and then we can start it. But normally the tools are run from integrated development environment, and that's why we do not have the need to start the tools. There we have again a startable Java archive. We could go again into x8664 and try to run this one. Maybe we can have it run. Yeah, I should type the correct word. So no main, yeah. And we see here is SVT is the standard widget toolkit. Okay, we know this. We know the standard widget toolkit is part of this, so that we get a window. We could actually get a window from this monitor program here in tools, and this is the monitor batch file. Oh, maybe we try this one. Let's try this one. Oh, we do not get any error messages. This is fine. Okay, we go up and try the batch file. An error occurred, so we have the error again in the configuration. But this batch file could maybe set the right class path. The error occurred again, so in configuration, where was the error? Once again, tools lib monitor configuration. The latest version of this, was that one, and let's try to have a look. Seven one two 5415. This is the one. The same. Yes, as you see, now it is Eclipse Core runtime 3.8 and so on, but okay. Normally these tools are started from the IDE, that's why we don't have to care about this at the moment. If you want to get it run, you can and fix those error messages to say, okay, this is somewhere in my class path, and then he can find it. It could not be resolved. It means misses here something. But it's not worth to spend so much time now here in the lecture, because it's boring. This is our Android SDK, and there is the tool chain inside. We can build and produce Android code with the help of our SDK. So sources, here are some sources. We have Android sources inside, and there is Java code, activity Java, or intent service. Where is it here? Yeah, very important things. The sources are installed for this API version 30, so you have always the chance to go into a source file. This is important for the IntelliJ IDEA as well, so you can access the source files if you write own code and say, okay, I want to see how it is done in this Android framework. I just click on the method, and then the file is opened, and you are coming into the and then see this. So you have everything here for build and develop really good code and fulfill everything the Android or the IntelliJ IDEA can use. So we could use the code completion because the code is available. The sources for this file is there. And this is here a very professional file. You see so many information written down here, and yeah, it extends just one class, but it's a wrapper class. You see, this wraps some things, and there we have implementations of lots of interfaces. Really interesting to have a look sometimes and to see how other programmers do their stuff. Sometimes really interesting because it's really the source code, and so we have the methods here as well. So if you want to say how is it done, this set content method weitersuchen, set content view, maybe should calling set content view. So we are now similar here in the on create method. You see this on create method. If you those developers from you who already programmed Android, maybe you haven't taken a look before into this code and want to see, okay, how is it made. So we have a conditional expression. If there's a debug lifecycle, then we get a log that this onCreate is running. So maybe you already have the need to debug your code, and therefore you could define this debug lifecycle thing, and then the Android system is debugging those methods as well. If you produce your maybe with debug symbols, if you compile your program in this debug configuration, you maybe get this to true, and then you get more output in a debuggable APK. And if you say it is a productive version, maybe then those are off, and the compiler leaves this empty. So on later we maybe take a little more time to have some eyes on code that is run here, if we are able to understand some easy code examples from Android, and that's why we should maybe inspect code from the Android operating system a little bit later, when we did our first steps and are able to make some things. That we can have a look what is done with my parameters if I use such a method. Good. Questions? Okay, this was the overview over the Android SDK. So we have seen there are some command line development tools. Not every tool on the command line, and years ago it was no problem. We could start every tool simply on the command line, but they changed this approach. Now it is normally that we run the tools in the IDEs. They are included. The main problem is the class path and the resolution of some Java archives that are used to start up our development tools. The next is the Android Studio, and I don't use it this time. I'm using the IntelliJ Community Edition, and now we go into our projects. Okay. If I want to do an Android project, I take my IntelliJ and say I want to have a new project, and then I can select the platform I want to program for, and here in this case I choose Android, and then I have the next choice to see what kind of project wizard I want to run. I can run a very simple thing with no activity, and there's standing no activity, or a basic solution with a basic activity. Maybe we start with a very basic thing for the first. We can try different things. You can try everything, and after each other, and have a look what you get if you use this wizard in this configuration or in that configuration, and so on. There are different things. Maybe a maps activity is possible here. We have a settings activity possible here. We have native code for the NDK, the Android NDK here. Some startups, but we mainly want to have either basic, empty, or nothing. So at first I would say, let's take a basic hello world program. This is what is behind a basic activity normally. So we go to this. The kind of Android, so we have Android things, automotive as well, or TV, Android Wear, those smart we play here on the phone, the smartphones and tablet. Let's go next. In the next step, we want to see, hey, go next, I said. Yeah. In the next step, we have to do some configurations. We have to give our application a name. Normally they're standing my application, and as you know, this IntelliJ is numbering projects or names automatically. So it starts with no number, and the next project will be my application 1, and then comes my application 2, and so on. What is very important is a package. in a Android project, you always need a package, and this package has to have at least this style. So you have to use a top level and a second level. Normally you use a domain approach, so you use some of the typical top level domains. In my case, I could use DE, and then I would give my distinct application a application or package name. This could be my application. So that's this is the one you have to do at least. You need at least, so DE is too short for a package name, so the package name must have at least one is standing down here, and that's why I should write something else, but this is enough for Android. I could use D.E. This would be enough for Android too, but it's not so nice for us to understand as humans. But you know this approach from Java. The package names are similar, so if I want to use Eclipse packages or something like that, you have org.eclipse. You could use so organizational things, or I'm here in Germany and I use my abbreviation like this, and then I place my application in my packages. And that's why later on when you install those applications on a phone or the emulator or somewhere, then this is the name of your directory. So this will be a directory name on the phone afterwards. We can see, we can inspect it when we use the debug bridge. Then we can see it. There will be somewhere a folder, and in this folder everything is stored what belongs to my application when it is installed on the phone. So this will be a file path later on, as you know it from Java. So it is typical. This will be a package name first, and in Java later on it will be a file path. And that's what it is. On my local machine, we save it in my IDEA projects, no problem. And if I choose Kotlin, I can use both. I can use Java and Kotlin. So it's a good thing for you to say, okay, I take Kotlin from start. I can use both. If I choose Kotlin here, I get a ready running program which already uses a Kotlin file, but I can use Java files in this constellation as well. But I don't have to decide for Java. If I use Java, I cannot use Kotlin. If I use Kotlin, I can use both. But the generated piece of code I get for this basic activity will be Kotlin. But for us, no problem, because we want Kotlin to use. We want to use Kotlin. Here we have a special checkbox giving us or importing some support libraries. This is for downwards compatibility. If you want to use older API versions in newer phones, you should use it, but you don't need to use it. So to leave this out, we want to use the APIs in their form as they are available from the operating system, without the need to use additional libraries. And this choice is the least API level your code is running for. In our SDK API version 30, we can say, okay, my application I am building is compatible with APIs from API version 16. So not every API has changed during the evolution of Android. So there are some things that will never change. This is the activity, this is the intent. Those classes will always be available on every phone, from the first version to forever. So this is the basic concept. So if I just use some basic things which will not change over the years, then I have the I have no problem to say I can use any of these versions. But, and if I use special things which are new, very new, then I only go back to this API version when those methods and classes were coming out or came into Android. Yeah. Then I have just this this region where I can choose my API version. And according to the API version, you see on the right side, there belongs the Android operating system version. So if I go to API 30, I'm starting with Android 10 and 11, just the newest ones. And if I say, okay, I'm a beginner, I start with the basic things, I can go back to the oldest. And what you see is that the API version 30, the one I'm programming for, is only compatible downwards to API 14, so Android 4, the ice cream sandwich. I can't go further to the back. If I use a other SDK, a older SDK, I could go back more far back in time. And the standard way is the 4.1 here. I just leave it, and here down here you see it is your application is running with 99.8%. If I choose this version, I have only 8.2%. And if I go to the 30, I have not really 1% compatibility with devices out there in the field. So if I go back to 14, I have 100%. This is maybe not the reality, because we don't know if there are any devices out there which use those Android 4. This device here is using Android 4 with KitKat 4.4, yeah, for the next maybe 1-2 years, and then it is over. So then I am out of this line here. Okay, we stay in version 16 for this time. If you need some more help, you can go help me choose. This was everything. So we have a name for our application, we have defined a package, we have chosen a minimum SDK. We can switch to another version later, but this is fulfilled in this step once, and later on, if we look into our project files, then we can find this information again, and if we want to change it, we can change it in the code. So finish, and we now get, after some seconds, in this video, I have the ability to program for my Android things. Yeah, down here. Yeah, now it starts. So the next thing is my project has a problem and it failed to compile. I can try to build it, but it will fail again. Now this is called my application 3 because I already have a application called my application and my application 1 and 2 and so on my file system. So this is actually application 3. It will not compile. Why? This is a generated project and I get generated files, and mainly it fails because of Gradle. So this error message here is coming from the Gradle. It is standing under sync, and this synchronization is done with the Gradle build toolchain. To fix this problem, I go into my project, and you see this is a main Java project, but we have Kotlin and Java code. And I go to my build Gradle, not in the main, but in this source from my application. This is the module. This is the project name, my application. In this project name, I have one module is the app, the mobile app. I can have several modules. I can have a big project with several applications, mobile applications in there. So this is only one mobile application called app, and there I have a build Gradle file, a build file, and in this build file there is somewhere standing a build tools version. I have to look where the build tools version is standing. Okay, not here. Let's have a look at the other build Gradle file. It's outside the app module. It's a project-wide Gradle build file. This is a Gradle build file project-wide. We have their information. It's not the information I'm looking for, so I go to settings.gradle. This is not the right file. I go to Gradle properties. It's not the right file, so I'm looking for the right file. Where do I find the right file? Gradle wrapper. It's the Gradle wrapper. Okay, it is the Gradle, and the Gradle is in this folder Gradle, just with this wrapper. And in this properties file from the wrapper, I have the chance to say which toolchain, which Gradle toolchain to use. I can go to 6.7, and what happens then is that my Gradle toolchain has to be synced, and he downloads this file and uses the ingredients of this file to build my application module. So I can go and sync it to really our project. Now he is building the project. You see it is working yet. He downloads some stuff with only for the first time. But it does it always for every project, and this makes our projects really huge. So there are coming additional Java archives only in this project. And for every new project, you load them again. So if you make more applications in one project, it would be easier for you because you don't need to configure this project for every application you do. So you can include several mobile applications in one project called modules, and then you have several, and those apps have access to each other as well if you want. But for our first start, we want to make a new application in there. So this downloading is only done once, but it takes a little time, and now it is successful. So the build is finished. Now it is successful. I can close all those files, and then we have a look into those files later on. So you have seen there's not only one configuration file for my project, there are lots of configuration files for my project. I close everything and go back again back into this structure. What have we in this structure? Let's have a look in on our slide. On our slide we have the project structure, and there is a output directory, there is a manifest, there is a source folder, and there is a res folder. We analyze it in the IntelliJ IDEA. I open up my project and I find there some Gradle stuff here. This is the Gradle 6.7. I downloaded it at the moment. Before I had the 6.1, but my project did not work with this here. So here we have download things in and configurations in this folder. Okay, then we have .idea. These are configuration informations for the project, the whole project made by the IntelliJ. So those informations are done by IntelliJ or normally automatically, and we normally do not have to change things inside of those two directories because they are invisible for us with this dot in front. We have our work begins normally in this folder, in this application module, and the subfolders of that. This is the part where we normally have to change things, and the other stuff should work out of the box. But you have seen this Gradle stuff sometimes makes problems, and that's maybe according to not to have the right version. Mainly it is this that's the problem, not to have the right version. So okay, So let's go into this application. This is our place where we have to work with. We have a library folder. It's actually empty because we do not need external libraries. If you program for devices which have maybe hardware which is not standard in the Android operating system, maybe you have a device which uses a pen and you have a pen enabled device and you can write on your tablet or your smartphone with a pen, then you need a other API which is not standard in Android OS to access this hardware, and therefore you could use external libraries from your manufacturer, so proprietary files. You have to include in your application and you have to load them later or access them via the APIs of your manufacturer. But in our case, we leave this year we leave this empty. Okay, the other thing is source. We are sure we find our source code here, but if we open it up, we see 3 more folders. We have a Android test folder. There is a example test instrumented test inside, so there is already code inside which tests our application. It is Kotlin code because we have chosen to write Kotlin or to make a Kotlin project, so the generated code we have here is already in Kotlin, but we can mix it with Java. We have just easy to write down a Java file and then it is Java code. So we already got some things here. If we want to test, this is already integrated to write own tests. There are example unit tests, how to write your tests for your own classes. So those are functional tests, classes tests, so unit tests. So far. The next point is this main folder, and this is the main sources folder. There we find everything we have, which is very, very important. The most important things we have here. So we just have to go down this way to this main folder, and then we find the Java source code mixed with the Kotlin source code in one source folder, and the resources folder where we want to talk about maybe next week or the week after next week, the over next week. And we have a Android manifest file. Okay, output folder, we have as well a output folder, but this output folder is not visible now. To get the output folder visible, I have to start my application package, what I will do so far now. If you do this for the first time, we'll see here up here, you will have the need to have a running configuration, and for this you have the need to have a device. To create a device, you use the AVD manager. This is a program from the Android SDK. We had a look earlier into this Android SDK. There is a manager program, AVD manager. This AVD manager is able to create new virtual devices. We choose one of those devices, and here you see something you have already seen earlier today. Here are the skins listed with the device resolutions, and we just choose a skin. Maybe we want to have a skin from a Android Pixel 2 XL, then this will be our configuration. We have a large size and we have a pixel density of 560 dots per inch, and then we can go next. And then we have to choose the virtual machine or the operating system image which is running on this emulator device. So we have to choose the emulator engine, the back end, and the front end is just an image blended over the running virtual machine. So we could use everything with every other thing before. So we can choose any of this and combine it with any of this. Those are quite huge, so some gigabytes size. Normally you take one down and use it. So I think I have the API level 27 with Android 8.1 and the Google APIs enabled. here. I think I have chosen this one, so it's preferably chosen. The other ones I would have to download. You see this here? This is a link. If I want to use those other images available, I have to download it. And this is a thing I won't start now because it takes really long. Those files are really huge, some gigabytes in size. That's what you have to do, and then you go next and finish, and you get a emulator like this here. I prepared already a Nexus 1 with the API 27. You see it is the Oreo image with the Android 8.1 running on this device, and on the disk it is 3.7 gigabytes, so you won't install every image, I'm sure. So you just decide to take one, or maybe a second one, another one, but one is enough because you also have your smartphone as a real device, and then you can use this real device too for debugging or installing and testing. This window cannot be closed again, so I should not have opened it. I can't close it. Yeah, it is not closable. In the Android Studio you can close it. The Android Studio has surroundings which the common platform does not have. So if you start up this program once, this window, you can't close it. It's not closable. Only like this maybe. Yeah, like this. I can close it like this. But you have seen the surroundings, the decoration was missing, and the Android Studio, if you use the real Android Studio branded IntelliJ, I think you have surroundings, or you have the decoration to this window too, and can close this AVD manager. So far, if you have a emulator device, or you have a developer tools enabled smartphone connected with your PC, then you can run your application on this device. And then this play button is enabled so that I can run this application. If I do this now, and I will do it now, the Nexus 1 is started up. Here you see it. Okay, no problem. I don't know, this message has not come before. This is the first time I've saw this message. So this device now starts up, takes a little time because in my system now are several processes running on the OBS Studio and the Zoom, and now I'm starting again a virtual machine, taking lots of CPU power from my main CPU. That's why it could take a little while. Here you see some running tasks. So the DEX task was running, the package task was running, and now it finished here. The build has finished. It was successful, and when the build has finished and was successful, we normally should earn a output folder somewhere where to get some outputs. And if we don't see that, we can go to project files, go into our project, and should then see somewhere a build or output folder. So here we have build, Kotlin and sessions. There's nothing inside at the moment. And other output folder, where is it? Build, here it is. Here is the output of my program, the APK, and here's the debug APK. This is the outcome of this compile run. We get an application package. This application package can be copied onto the device via the Android debug bridge. We can use it from the command line as well and copy this file on the device, and then give an install command to unpack this package and create a folder where all the ingredients from this application package are extracted into. So next we'll have a look at the device. This is my device, and the device is black. I don't see anything. Why it is black? It is not really working at at 100%. Now here it is. So it was black because of I just took the switch on the side, on the right side. There's a switch on every smartphone where I can make the screen, where I can power off the screen. So this is this button. It is here like a power button. And you see Control P is this power button. Now you see the application, my application. So is it called? It is a hello program. I have a button. So this is my basic application. I can have there's a menu included. There are some things here included inside, and you can go play with this. Okay. So this is the power button. The device stays running, and I just switch on and off this screen. I can switch the device, and you see the emulator is doing what a real phone would do as well. So if you switch the mode of the viewport is changing from landscape to portrait, from portrait to landscape. So this is called the portrait mode, and if I do this, it does not change. So this is the bottom is up. We stay in landscape. If I change it again, we have it like this, stay in landscape, and if I go back to this, I have portrait mode. This is done. I can go to screenshots and make screenshots of my application or something. I can control things from the hardware buttons. So some devices have hardware buttons, and if I want to use them, they are not able, they are not part of this image. Oh, this is power off. I don't want to power off. There is a button on this image. You see it on this side. It is from here to push from here. If I click here, I get this button push, and this is the power button of the device itself. And I can say, if I click it longer, if I click it long, it was a long click, I can restart or power off this device. So now it is shut down. Again. So, okay, this was my brief introduction so far, because the time is already over. Have you any questions? Shall I show you some more interesting things? Or should we go and have a view into the code? Maybe we should have a small view into the code. So in this build directory, you find this outputs. APK debug is the debug version, and productive would be the productive version for this. For this approach, you can just copy your APK file and install it somewhere, everywhere you want. So the first sources we find, so 3 different files. Maybe next time we choose the wizard of the empty activity, then we become normally only 1 file. Here we have 2 fragments and 1 main activity. The main activity is a compatibility activity. Here we don't need compatibility activity because we don't want to make those compatibility things running. You see this on the name, this app-compat activity. We just want to have a activity which is coming from activity, but then some other stuff won't work. So next time we start with an empty activity maybe, and then we have the base class activity. Don't want those compatibility things if we don't see that we need it. Okay, what we've seen is just a hello world string given out, and you see this is Kotlin code. We have a class. This is the extension. This is no keyword extends. It is a colon here, and that's why we have Kotlin. You see it here again, and on other things. So we have lots of more. We need lots of more information how to read and write and understand those Kotlin code. For the moment, we never will see the hello world in here in this activity. We will not see it in this fragment, so there's nowhere the string hello world. It is found in the resources, under values, under strings. There should be all all text. So hello first fragment, hello second fragment with the arguments and so on. This is here down in this XML file. In those strings, we will find those two approaches, these two strings, these two names or identifiers we will find in our code. So the first fragment should use somewhere in its layout. This is the other thing, fragment first. There we should see this text string hello first fragment, and in the second fragment we should see the text where is ID constraint layout, where's the text? There is no text inside at the moment. This text view has no text, is not completely done. Here we have the text previous inside. It is coming from string previous, so everything is combined. Those files use information from those files and so on. It's time and over next week to talk about the resources. It's a very important thing in Android. There are lots of resources, images and so on, menus, but we will look in one lecture concrete only to resources, and in the next lecture we will look to simple activities. We write our first own activity and take some intents and make something with intents and program a little bit. Next week and the week afterwards we concentrate on the on those huge part here, resources. Then we have some basic, some fundament to explore more other features. Okay, so this was the lecture for today. I hope it was interesting for you and you got a brief introduction into this Android project, into have an overview over your SDK, have an overview and first overview over your project structure, know where to click to find your code, know where to click to find your output. You know to get around with problems like I don't have the right Gradle version, so use this build Gradle of your project. Use the Gradle wrapper file of your Gradle properties, those are wrapper properties, and change the version here. This should be the only place where you switch between the Gradle versions in this file. Yeah? It's important, because if you change things in other files, and there are many of those, this could cause additional problems you don't want. Yeah. Any questions now? Again, we make a little review at the beginning of the next week. We maybe have a look at the Android debug bridge and do some command line control, get in a shell, get in a logcat and so on. For next week, do some more on the project level. Okay? So I hope it was interesting for you. I wish you a nice weekend and we see us again next week. Please think that you should do exercises with Kotlin. I gave you the website Procon, where you can do exercises with Kotlin too. Yeah, you should be able to log in and do exercises and solve problems. Thank you very much. Have a nice weekend.
Thank you very much.
Goodbye.
Schönes Wochenende.
Bye. Thank you.
Schönes Wochenende. Auf Wiederschauen.
Auf Wiedersehen.
Wiedersehen.